Hello students, have you been struggling to find the frictional force in case of pure rolling? If yes, no need to worry. I have a magical formula for you. Using this formula, you can find magnitude and direction both in few seconds. So here is the formula. Here in this formula, small f is frictional force, capital F force applied on the object, m is the mass of the object, r represents radius of the object, y is perpendicular distance from axis of rotation to line of force, and I is the moment of inertia. To understand it clearly, let's take an example of rolling disc. I'll try to make you understand its application by applying the formula in 4 different situations in this example. So let's get started with the situation 1. In this situation, there is a rough horizontal surface and a disc is rolling on it. A force of magnitude F is being applied on it in such a way that its line is r distance above the axis of rotation. So this is our situation. Now, to find the frictional force, we will use the magical formula. Here in this formula, F vector will have to be replaced by Fi cap because this force is in the direction of positive x-axis. M will remain M, R will remain R. Here Y has to be positive R, as here line of force is above the axis of rotation. That's why we should take Y as positive R. Likewise, we need to take negative sign of Y if the line of force is below the axis of rotation. Here this I should be replaced by half mr square, as we know that moment of inertia of the disk about its axis of rotation is half mr square. Here numerator comes out to be mr square by 2 and denominator will be 3 by 2 mr square. Mr square and mr square will cancel each other. After simplifying it further, we'll get f by 3 I cap. Here this equation tells us the friction is along the same direction as the direction of applied force and its magnitude is F by 3. Now let's move to next situation. Here everything is same, but the only change is the position of line of force. Here it passes r by 2 distance above the axis of rotation. Now, to calculate friction force, here F will have to be Fi cap and M will be M, R will be R, but here Y has to be R by 2. As you can see here, line of force is above the axis of rotation. Here this term will be mr square by 2 and I is also mr square 2. So here we are getting same term with opposite signs. Now it's very clear that F will come out to be 0 here. So no friction force in this situation. Now let's move to next situation. Here in this situation, everything is same, but the only change is the position of line of force. Here it is passing through axis of rotation. Now to find the friction force, here in the formula, F will remain Fi cap, M will remain M and R will be R. But here Y has to be 0. As you can see, line of force is passing through axis of rotation. So no distance between the line of force and the axis of rotation. So here this term will be 0 and I will be mr square by 2. After simplifying the equation, what we are getting here is minus F by 3 I cap. So here friction is opposite to the direction of force applied and the magnitude is F by 3. Now let's move to next situation. Here in this situation, line of force is r by 2 distance below the axis of rotation. Right? So again, to find the friction, we'll use the same formula. Here F will remain Fi cap and m will remain m, r will be r, but here y has to be negative r by 2. As you can see, line of force is below the axis of rotation, right? So here this term will be minus mr square by 2 and I is mr square by 2. In numerator we have mr square and in denominator we have 3 by 2 mr square. Now this term mr square get cancelled with mr square, and what we getting here is 2f by 3 minus I cap. So here friction is opposite to the direction of force applied and its magnitude is 2f by 3. I hope you have understood the application of this formula. I will recommend you to solve some questions related to this topic to grip the concept. I have given a test link in description box. You can attempt this test as many times as you can. Okay, bye students. We'll meet again in next video. Till then, keep studying, keep growing.